Hello, everyone. Welcome back to the ZeusAI Podcast series. I'm your host, Priya, Chief Information Officer of Zeus Fire and Security. And I have to say, it's been a minute. If you've been wondering where the episodes went, same. I've missed being behind this mic and connecting with all of you. But I'm back. And today, we're kicking off something I've really been wanting to do, AI literacy. Now, before your eyes glaze over, let me say this. This is not about coding, not about becoming an expert. This is about making sure you as a business leader don't get bamboozled the next time someone says, we'll solve this with AI. Today is part one of a two-part series. We are starting with the fundamentals, and I mean real fundamentals, not definitions you forget in 30 seconds, but examples that stick. Because when you get how this stuff works, even a little, you unlock better decisions, better investments, and stronger leadership. Let's go. What even is AI? So let's strip this down. AI is not magic. It's software that finds patterns in data and makes predictions. That's it. It's not thinking. It's definitely not feeling. It's not the self-aware robot planning world domination. It's not your next CEO. Let me give you an analogy. Imagine you run a pizza shop. You notice that every time it rains, online orders spike. You learn that pattern and start prepping more dough when it's cloudy. That's AI in a nutshell. It's just learning from historical data to predict future outcomes. What makes it artificially intelligent is that you are teaching a machine to find those patterns and act on them without reprogramming it each time. So what's machine learning? You'll hear this term all the time. Machine learning, or ML, is the part of AI that actually does the learning. And again, not complicated. Let me show you how it works with a real example. Let's say you want to build a system to identify whether a photo contains a fire. You feed it thousands of images, some labeled fire, some labeled no fire. It starts to detect patterns, flickering orange, smoke trails, high pixel intensity. Eventually, you give it a new image, no label, and it predicts. This one looks like fire. Boom. That's supervised learning, the most common type of ML. It's like flashcards. The system studies enough examples and starts to recognize what's what. Where do you see this in the real world? Everywhere. Credit card fraud detection, email spam filters, predicting employee churn, recommending what to watch next on Netflix. But here's the twist. The machine only knows what you teach it. Garbage in, garbage out. If you only give it images of fire in forests, it won't recognize a stovetop fire. So the quality and diversity of your data is everything. Unsupervised learning, when you don't have labels. Now let's flip the script. What if you don't have labels? You don't know who is likely to churn or what email is spam. You have a pile of data and you want the system to find structure in it. That's unsupervised learning. Think of it like walking into a crowded room where you don't know anyone, and you start grouping people based on what they are wearing, who they are talking to, how they are behaving. That's what the machine does. These customers tend to buy together. These transactions look different from the rest. Maybe fraud? These users behave like power users. You didn't tell it what to look for. You just gave it the room and let it observe. That is used for market segmentation, anomaly detection, product recommendation clusters. It's how Spotify figures out which niche playlist you might love without you telling it anything. Now let's tackle the big, scary phrase, neural networks. Sounds like brain surgery, right? Let's go simple. A neural network is a layered system of tiny decision makers. Here's an analogy. You're applying for a loan. Your application goes through 50 reviewers. Reviewer 1 checks your credit score. Reviewer 2 looks at your income. Reviewer 3 checks your spending habits. Each one passes their judgment to the next group. Eventually, you get a yes or a no. That's basically how a neural network works. Each neuron does a little math on what it sees, then passes it forward. When you stack many layers of these neurons together, you get deep learning. Powerful, flexible, and incredibly effective. It's what powers facial recognition, ChatGPT, self-driving car vision systems. But here's the catch. Once you have had hundreds of these layers and millions of connections, it becomes very hard to explain why the model made a certain decision. You know what went in, you know what came out, but how it got there, that's where it gets fuzzy. And that is what people mean when they say AI is a black box. It's not intentionally secretive, it's just complex beyond human readability. Why this matters? If you remember just one thing from this episode, it's this. AI is not a strategy, it's a tool. And like any tool, its effectiveness depends on how well you understand it. As a leader, you don't need to build a model, but you do need to ask, what kind of learning is this using? What examples was it trained on? How do you know it's not missing the mark? Next episode, we'll dive into what large language models actually are, what it means when AI hallucinates, and how to tell if a model is trustworthy. But for now, I hope this helped pull back the curtain just a bit. If you're clearer on what AI actually is and what it's not, then I've done my job. Share this with a colleague who's still throwing around buzzwords. And send me your questions. I might answer them on the next one. Until next time, stay curious, stay bold, and don't forget to dream big.